Hello, this is Closer. Closer is an Internet of Things claw machine game that allows users to play a game from a mobile app. This project features a custom-built claw cabinet from aluminum extrusions with cameras to view the cabinet from different sides. The cabinet, backend, and mobile app work together to provide users a game experience at the comfort of their mobile device. Starting with the cabinet, we modeled our frame in Fusion to ensure that we ordered the right amount of extrusions at their proper lengths. Our first draft had L and T brackets from Misumi. However, we found that it added a significant cost to the frame. Our second revision only kept L brackets where they were near panels and kept normal corner brackets everywhere else to help reduce costs. We also adjusted our dimensions to be more taller and to fit a claw gantry kit at the proper width. Our final revision kept the design, but used other L-style brackets to help bring the overall cost even lower. Designing the frame in Fusion allowed us to easily assemble the frame and to cut panels at their appropriate size. Once we ordered our parts and assembled the cabinet, our final result looks like this. Our final panels consisted of 2 acrylic panels with a cutout on one of them for quick access and hardboard for the rest. We also added an LED strip along the top to better illuminate the inside for the cameras. On the bottom, you can see other components used to operate the cabinet. These include a computer along with a microcontroller and the motherboard from the gantry kit. For the microcontroller, it is a Pi-Pico-based controller and uses optocouplers to close the circuits that are used for user inputs and the coin mechanism. Through the use of optocouplers, we can ensure that the circuitry of the gantry motherboard doesn't directly interact with the microcontroller, avoiding possible damage to either component. This little schematic on the side shows the circuit for one of the inputs to the motherboard. It includes an indicator LED and resistors to prevent the burnout of the LED. This circuit is replicated for every input of the gantry motherboard that we need. To interact with the microcontroller, the computer connects to it via serial, and the client application essentially mimics a person playing the game. The computer running the client also runs OBS Studio to stream the video with the 3 different views, and allows users to toggle between them. 2 of these cameras are located on the sides, and 1 is on the claw itself. A 4th camera is also separated off OBS to be used as part of a computer vision-based prize detection mechanism. It uses article markers, and if the camera can't see all the markers, it outputs that a prize has been won. The computer client handles all of these components and sends a WIP video stream along with a WebSocket connection to the backend. Our backend consists of 3 virtual machine instances in Google Cloud, one each for the actual application and play data, another for the database, and the last one for proxying the video stream to users. The backend handles authentication with Google, supports multiple cabinets, and handles queuing of users on a cabinet. The backend essentially provides a meeting point between the cabinet and users through WebSockets and proxies the video using Media MTX to the mobile application. The mobile application was first prototyped in Figma, allowing us to collaborate and generate ideas for the interface of the app. Once we decided on a design, we developed the app with React Native and used a pixel-style theme for the design. The app implements the Google sign-in, pulls the video stream from the backend, and connects it via WebSockets. This image shows the various prototypes of the UI design, which included different layouts of the buttons and other elements before we chose our final version, which looks like this. These images are from the different screens users interact with. These include a profile page, a list of cabinets to play, a price page, and a token shop. Finally, we have the demo showing everything working together. These screens show the gameplay interface. The left image is shown before attempting to play a game, the middle shows you someone else playing and you spot in the queue, and the last one shows the game controls when you're playing a game. This first video demonstrates navigating through the app pages and shows a scenario where you don't win a prize. You can see OBS from the computer along with the PC client program logging of what it receives. Due to constraints of the gantry motherboard kit, we provide a viewing time where users can look around the cabinet to decide what to aim for. Afterwards, we unlock the clock and controls and let users operate the cabinet. It's a bit hard to see in this case, but the prize detection runs after the claw returns home and checks the camera 3 times to see if a prize has been won. The computer sends a 1 or 0 to indicate a prize, which will then end a user session. Following shortly, a 2 is sent to indicate that the cabinet is ready for the next user. Now, this video shows a scenario where a user wins a prize. It is identical to the previous demo, with the exception of winning a prize. After a prize has been dropped, you can see the new images the prize detection creates, showing the checks it did. While the PC client sends a proper message, the app screen showing a prize won is still a work in progress. Thank you for your time.